How do you balance half reactions in acidic media and basic media? How do you do it? So we want to look at how you can balance these half reactions. What does it mean? Like from this question right here, that's saying we should balance the redox reaction in acidic medium. What does it mean to balance these half reactions in acidic medium? So today in this video, we want to look at a part of electrochemistry that allows us to balance these half reactions in acidic media and basic media. So we'll start with the first thing here, basic media and acidic media. So I'll write down the half reaction that has been given here. In fact, this redox reaction that has been given is MnO4 plus NO2 Mn, that's a 2 plus there, plus NO3. So the question we're looking at here today is this question right here. How can we balance this half reaction in acidic medium? This question right here, question C. So right now you can write it down and then we see how we can work out this question. I hope you guys have noted down the question or you've written it somewhere so that you can be able to follow through. I should create enough space for myself here so that you can see whatever I'm doing. So let's get into it. So this is the half reaction that has been given here, or the redox reaction. Remember from the introduction to redox reaction, we said a redox reaction is a reaction that is undergoing reduction and oxidation. And we also gave brief descriptions about reduction, we gave brief description about oxidation and what they mean. So let's look at this question here. So the first step that you're going to work out here is you need to balance the number of electrons, and you also need to balance the number of atoms for each half reaction. So the first step, we're going to make half reactions of this redox reaction. Let's make half reactions. The first half reaction we're going to get is this half reaction with that half reaction, with this first part here, which is MnO4 going to be equated to Mn. And you must make sure that there's a similarity in terms of the compound that you're equating to. Like from the side of the reactants, you've got manganese as Mn, and on the side of the product, you've got Mn as well. So you know that there's a very big similarity there, so they must go together to form up that half reaction. So that half reaction is only formed from the similarities in terms of the compounds that we have in this reaction, this redox reaction. So we know that the first thing that we're supposed to do is balance up the number of atoms, then balance up the number of electrons. How many atoms of manganese do we have here on the side of the reactants? I've got one atom here, but 4 atoms of oxygen. And then since we've got the 4 atoms of oxygen on the reactants, that means we're supposed to add 4 atoms of oxygen on the side of the product for them to balance up. But oxygen will be added in a different manner. You're going to add it in form of water because you know water's got atoms of oxygen. So we're going to say plus 4 H2O. So in trying to solve a problem, you're creating another problem. So I've got 8 atoms of hydrogen here. So since I've got 8 atoms of hydrogen, you know you're supposed to balance up on the side of the reactant. So I'm going to add 8 atoms of hydrogen on the side of the reactants. I'm going to have 8 here of H plus Mn O4 Mn 2 plus the 4 atoms of oxygen. So the 4 water molecules that are here. Now I've got 4 atoms of oxygen on the side of the reactants. I've got 4 atoms of oxygen, 1 atom of manganese, 1 atom of manganese, 8 atoms of hydrogen, and 8 atoms of hydrogen. So I've balanced up the number of atoms in this half reaction. What's the second thing? Balance up the number of electrons. How many electrons do we have on the side of the product of the reactants, first of all? But we've got 8 times the positive here. We're going to get the 8 here. And then here we have 1 there as the mole ratio times the negative here. We're going to have 1 minus 8 minus 1. So on the side of the reactants, we've got 7. How about on the product? We've got a 2 here. And here there's a 0. So we only have 7 and a 2 here. On the reactants, we've got 7. And on the product, we've got a 2. So what do? Remember what we're doing. You find the difference between 7 and 2. That is saying 7 minus 2. It's going to give a difference of 5. And the 5 will be added on the side of the reactant. So the side that has got more number of electrons. Because electrons are negatively charged. And when they're added on where we have more, they're going to subtract so that we can have equal number of electrons with the product. So I'm going to erase this off. So 5 number of electrons here. I'm going to say 5 electrons plus the 8 H plus the Mn O4. We have that Mn 2 plus the 4H2O. So how many number of electrons we have now? That is the 5 minus 5, negative 5 plus 8. We're going to have negative 3. Negative 3, we're going to have negative 5 here plus 8. Negative 5 plus 8, we're going to have a positive 3. Positive 3, there's a minus 1 here. We're going to have a 2 on the reactants. How about on the products? We also have a 2 here. So you know that this half reaction has balanced up. We've balanced up the number of atoms, and then we've also balanced up the number of electrons. So the first step is put up these half reaction, and don't make sure when you're equating these half reactions you get the similarities in terms of the number of in terms of the compounds. I've got the manganese oxide, it will go with the manganese. Then you balance up the number of atoms before balancing up the number of electrons. So that is how it works out. And then I will get the second half reaction there. That is MnO2, which is going to go with the NO3. And then we'll have 1 electron there. Then we also have 1 electron here. How many atoms of oxygen do I have on the side of the reactant? 2 atoms of oxygen. On the product, 3 atoms of oxygen. So I'm going to add 1 atom of oxygen this side. I'm going to say H2O plus NO2 here. I have that, which is going to give me NO3 and that. So 3 atoms of oxygen on the product, 3 atoms of oxygen on the reactants. In trying to solve a problem, I'm creating a different problem. So what problem is that? The number of hydrogens. 2 atoms of hydrogen on the reactants, but I don't have them on the product, so I need to balance up. So plus 2H plus. So now, since I've added those ones, I've added the protons, the 2 protons there. So I've got 2 protons here, and then 2 hydrogens here. It's balanced up. So the number of atoms for this redox reaction is balanced up because I've got 2 atoms of hydrogen here, 2 atoms of hydrogen, 2 atoms of oxygen, 2 atoms of oxygen, 1 atom of nitrogen, and 1 atom of nitrogen. What's the second thing? I need to balance up the number of electrons. For the number of electrons, let's check. So here this is a 0. That is just a negative 1. Remember, this is a subscript for the oxygen. This is not the mole ratio for the NO2. The 2 is the subscript for the oxygen. Don't make the mistake of multiplying 2 by the negative here. So we only have negative 1 this side. How about this side? We've got negative 1 plus the 2. And negative 1 plus 2 is going to give us a positive number. That is a 1. So what do? We have got a negative number of electrons here. And we've got positive number of electrons here. So what do? So here we only have 1 here. And if you find the difference, you say 1 minus or negative 1, we're going to get a positive 2. And if I put positive 2 where we have got more, because this is less, a negative number is less than a positive number. So to mean a positive number is bigger than a negative number, we know that. So we have got more number of electrons here. So I'm going to add 2. So if I add 2 electrons here, what am I going to have? I'm going to have negative 1 right here plus the 2 minus the 2. So 2 minus 2, that is a 0. I'm going to have negative 1. So on the side of the product, I've got negative 1. On the side of the reactants, I've got negative 1. So you know that the number of electrons for both half reactions are balanced. And this is fine. We're good to go. So remember the main thing, we're balancing up the number of what? The number of electrons. So after balancing up the two half reactions, we've balanced up the number of electrons and we've balanced up the number of atoms. The second thing we're supposed to do here is we're supposed to put them down. So I have the first half reaction that is right there, and the second half reaction is 5 electrons there, plus the 8 H plus the M N O4. I've got Mn 2 plus the 4 H2O. So I'm going to cover them up right there, and I'm going to cover them up right here, because the second thing, I need to balance up the number of electrons so that I can come up with one reaction. How many atoms are balancing, how many electrons are balancing up the first half reaction? That is a 2. How many electrons are balancing up the second half reaction? That is a 5. So how can I balance up such that I have equal number of electrons to come up with one equation here? So what I can do here is multiply the first half reaction by 5 and then multiply the second half reaction by 2. Why am I doing that? Because when I multiply 5 throughout, I'm going to have 10 number of electrons here. And when I multiply 2 throughout this half reaction, I'm going to have 10 number of electrons. So I'm going to have equal number of electrons for the first half reaction and the second half reaction, and then I can add them up so that I can find the difference between the two and get rid of those electrons and come up with one overall reaction. So let's work it out. So after doing that, I'm going to have 5 atoms of water here, 5 water molecules, sorry, plus the 5 NO2, 5 NO3, plus 5 times 2. There's a more ratio of 2 here, so the 2 will be affected by the 5. We're going to have 10 H plus 10 electrons. On the bottom part, we're going to have 2 times 5. We're going to have a 10 plus 2 times 8. We're going to have 16 H plus the 2 times, we're going to have 2 MnO O4. Remember, we still have that there, and then the 2 will also affect the manganese there on the product, plus the 2 by the 4 here, we're going to have 8 molecules of water. So second step, let's add the 2 half reactions. By doing that, we can get rid of small things from here. We can get rid of the 10 here. We can get rid of the 10 because this we just subtract, and we're going to have 0 number of electrons. The 10 minus the 10 will go. What else can we reduce here? I've got 8 atoms of water here. So these 8 atoms can subtract with that. You know that if I subtract this from that, I'm going to remain with 3 molecules of water. What else can I get rid of here? I've got 10 hydrogens. So these 10 hydrogens can go, and this I can remain with 6 because subtraction is happening there. The more reason why I'm doing this is just to simplify my equation, because you can't really have an overall reaction where I've got so much, and when you can simply adjust the numbers or simplify them to the lowest terms. So make sure that when you're working out such kind of equations, and when you're trying to find this half reaction in acidic medium, simplify it as fast as possible. So now we have 0 here. We're going to get the reactants. I'm going to have 5 NO2. I have that. Plus, remember this was subtracted. I'm not going to get that. And then here I only have 6 hydrogen. Then plus the 2 MnO4. I'm still going to maintain that, which is equal to what? I've got I just added the reactants. I got the reactants of the first half reaction, which is the 5 I got right there. Then plus the 16 atoms of hydrogen that remain that I've put here, plus the 2 MnO4 or the manganese oxide. I just added the reactants. Now let me add the products. This is 5 NO3, 5NO3 plus, this is 2MN, that's a 2 plus. Then the other thing that you must know here is this left us, and then we had 6 atoms, that this is gone. And then here we had 8, but because of the 5 that we subtracted from the 8, we have 3 molecules of water that remained. So now this is the half reaction that you have in acidic medium. How do you know that this is an acidic medium? What is the basic composition of acidic medium? When you've got protons, and when I mean what I mean when I talk about the protons, I mean the hydrogen atoms that are there. They symbolize the acidic medium. When you've got hydroxides, that symbolize the basic mediums. So what we have here are the protons. So this is symbolizing the fact that this half reaction was balanced in acidic medium. If you want to balance this half reaction in basic medium, we're going to add the hydroxides that we can form water molecules, and then that works out like that. So this is the answer that you're going to have this question. This is how it works out. So before you go, you must make sure the number of electrons on the side of the reactants are balanced with the number of electrons on the side of the products, and the number of atoms for each compound must be balanced with the number of atoms on the side of the products. So let's find out. So here I've got -5 plus 6 right there, minus 2. What is -5 plus 6? That is a 1. A 1 minus 2 are going to give me -1. So on the side of the reactants, I've got -1. Let me find out this side. This is -5 plus 4 plus 3. What is -5 plus 4? Sorry, this is -5. This is plus 4, and this is a 0. There's no 3 there. So this goes away. There's no charge here. So you know that the oxidation number of an atom of a compound is 0 at its room temperature. So this is going to be -5 plus 4. I'm going to get -1. So you see that on the side of the reactants, I've got -1 here. On the side of the product, I've got -1. So when you know the number of electrons are balanced, you know that also the number of atoms on the side of the reactants and on the side of the products are balanced. And there's no need for you to find out. But if you've got enough time in the exams, you can still find out. 6 atoms of hydrogen here. How many atoms of hydrogen? That is 3 times 2, that is 6. How many atoms of oxygen? That is a 3 plus the 5 by 3, that is 15. 15 plus 3, 16, 17, 18. We come here, that's 5 times 2, that is a 10. A 10 plus the 8, we're going to have, that is 2 there, 2 times 4, that is 8, that is 10. We're going to have 18, this is 15. 15 plus 3, 16, 17, 18. So the number of oxygen atoms on both sides of the reaction are balanced. And the manganese 2 here, we also have 2 right there. So everything is balanced. The nitrogen 5 on the side of the product, we also have 5 atoms of what? Of nitrogen. So guys, this is how you work out chemical reactions this is how you work out half reactions, and this is how you balance them in acidic medium. So basic medium, we're just going to add hydroxides that we can form water molecules, and that's how everything works out. So hope you guys got something from this video, and this is Pomoloka Blessings signing out. Thank you.